Greetings and welcome, friends. Mr. Waddy here. We are talking about some special parallelograms for all you special parallelograms out there. We're going to talk about rhombuses, rectangles, and squares. A rhombus, me and my buddies, we were just saying that a rhombus is a parallelogram with four congruent sides. I asked them whether or not you could have a quadrilateral with four congruent sides that was non-parallelogram. Their answer was no, because parallelogram opposite sides theorem, right? These are, it's a parallelogram. So a rhombus, four congruent sides. A rectangle is a parallelogram with four right angles. Interesting. And then a square is a parallelogram with four congruent sides and four right angles, which I have officially suggested to the International League of Math Friends that they rename squares rhombangles. Or a rectombus. I think with the H there sounds better. Rectombus. Yeah. Because it's the cross section of a rectangle and a rhombus. So great. Rhombangles. Also, maybe if I get another son, rhombangle might be a great middle name. Middle name, I think. Yeah. So who knows? Maybe someday there will be a rhombangle Waddy. Yeah. Maybe someday. But now you'll remember that squares are the cross section of those two things. Interesting. The rhombus corollary, it says if a rhombus, a quadrilateral is a rhombus if and only if it has four congruent sides. It's a corollary, not that great. It's kind of like a short step from the opposite sides converse for parallelograms. The rectangle corollary says a quadrilateral is a rectangle if and only if it has four right angles. Notice that these are biconditional, so you could prove vice versa. All right, so if rectangle, then four right angles. If four right angles, then rectangle. Right? I also have, the square corollary. I think, I almost lined that up pretty great. There, nope, that's fine. Quadrilateral is a square if and only if a rhombus is, it is a rhombus and a rectangle. Excellent, excellent. So guys, you know about Venn diagrams, right? I really like this sketch. Actually, you might be asked to reconstruct this Venn diagram on your own someday, just so you're aware. Imagine the world of quadrilaterals. Actually, yeah, outside of this, I could draw a bigger box, which would be like quadrilaterals. All right. What would be in the quadrilateral family that's not in the parallelogram family? Yeah, trapezoid. Right. Or just like any old crazy, like, irregular sort of four-sided polygon. And then outside of the quadrilateral family would be like, polygons and things like that. So let's see, inside the parallelogram family, right, parallelograms are defined as opposite sides being parallel. They look like that. Then we've got rhombuses in that family, we've got rectangles in that family, and then the one that contains all of the properties is a square. Lovely, lovely, lovely. So these are some special quadrilaterals. I think you'd agree. Okay, here we go. Let's see what happens here. Example 1. Using properties of special quadrilaterals. For any rhombus, cursed, decide whether the statement is always, sometimes, or sometimes true. Draw a diagram and explain your reasoning. All right. If angle Q is congruent to angle S, is angle Q congruent to angle S for a rhombus QRST? Is that sometimes or always true? Bing, bing, bing. Bing. Now, the order of this name matters. I have to name that in sequence, right? So always, yeah, because why? Well, because if it's a rhombus, then it's a parallelogram. If it's a parallelogram, parallelogram opposite angles theorem, right? Parallelogram opposite angles theorem is why that's true. How about is Q congruent to R? If that rhombus is a square, then they would be congruent. But in any other rhombus situation, Q, R, S, T. Yeah, a rhombus is a diamond, essentially. So these angles would be supplemental but not congruent. So this is sometimes. So in square situations, it works out. Right? Good stuff. Good stuff. Ooh. Ah, man, this feels kind of easy-ish so far. Look at this. Name that shape. Rhombus. It's in the quad family. It's in the parallelogram family. Why is it in the parallelogram family? Posk. Apparently, yeah. So posk is why that's a parallelogram. It's a rhombus by the Rhombus Corollary because opposite sides are congruent. Is it a square? No, it's not a square because this angle is going to be 70. This one's going to be 110. Yeah, so you're correct. There will be some problems on the test like this. If you answered parallelogram, although you're correct, it is a type of parallelogram, it would not have been the most specific answer, which is what we would have been looking for. So guys, turns out some rhombuses have some properties, or should I say all rhombuses have these properties. Check out this. Rhombus Diagonals Theorem. What was true about the diagonals of a parallelogram, regular parallelogram? Yeah, for parallelogram diagonal theorem said that for any parallelogram, right, that the diagonals bisected each other, right? In a rhombus, this is claiming that a parallelogram is a rhombus if and only if its diagonals are perpendicular. That's intriguing. Wow. And then also ρ it turns out that the diagonals of a rhombus are angle bisectors for the angles that they connect. Yeah, the vertices of those angles that they connect. So that's cool stuff. That's cool stuff. Let's see. Let's look at example 3. Example 3. We learn some properties and then we apply them. All right, here we go. All right, find the measures of the numbered angles in the rhombus. All right, we can go in any order. Someone give me something. Which one? You could call it angle 2, or angle 3, or angle 1. I'm not sure which one you're talking about. This one? Well, anyways, someone jump in here. Tell me angle 1, 2, 3, or 4. So because of the Rhombus Diagonals Theorem, 1 is equal to 90. I agree. Why is that? No. All right. So that's going to be 61. What else do we know? How about angle 3? Going to be 61. What was the name of that theorem that we just learned? Yeah, the Rhombus Opposite Angles Theorem. Okay, how about 4 now? All right, 3 and 4 are going to be complementary to each other because they're in a right triangle. So what's that? $29. Yep. Your book suggested the triangle sum theorem, which works. All 3 of those add up to 180. Yeah, that works. But also the